My land cover career really started in 2002 with biggest wildfire in Oregon's history, and that was the Biscuit wildfire. I, at the time, was doing botany surveys and looking for rare plants or rare mushrooms, and so I was spending a lot of time out on the forest looking at and taking photos and doing the documentation that a scientist or a land manager does. When that fire happened, it changed everything, because we all had to react to this fire that was burning up some of the places that I'd literally been the day before. And it was mapping what was there and what was under threat, but it was also mapping the effects of the fire. We needed to find a way to look across 500,000 acres. And the only way that we could really do that was satellite data. If we can't get out and actually measure every single thing, what are we missing? And that's where citizen scientists can actually come in and really help traditional scientists to better understand what is happening around them, but also fill in these gaps.
The Global Learning and Observations to Benefit the Environment program is an international science and education program. It provides students and the public with the opportunity to participate in data collection and the scientific process. The Globe Observer app is one of these opportunities, allowing citizen scientists and students to take land cover observations around the world and submit them to a larger database. But what exactly is land cover? Dr. Eric Brown de Colston of NASA's Goddard Space Flight Center explains.
Land cover is really the basic form of the landscape that we have around us. So whether it's a forest or a desert, but it's really one of the components of the landscape that we can study from space.
Dr. Peter Nelson is a scientist who uses land cover imagery in his research.
I am a remote sensing scientist who studies land cover across the globe. I use satellite imagery to make maps of land cover and try to quantify what covers the Earth. Sometimes a satellite can't see what's happening underneath a tree canopy or what's happening underneath cloud cover. And so we really need people to go out there and to take these photos, to do these observations, to help fill in where a satellite can't actually make some observations.
Just like any digital photograph, land cover images are made up of a series of pixels to show what covers the Earth. A pixel, or picture elements, is the smallest unit of a digital image. When combined with thousands of other pixels, a picture is formed. Each pixel color shown represents a land cover type. It's from these pixels where ground verification or ground truthing come into play. You see, depending on what satellite is taking images, a pixel can cover roughly an area of 30 to 500 meters squared. For imagery captured by Landsat, a pixel is 30 meters squared, or about the size of a baseball diamond. However, part of that pixel showing forest might actually be water or shrubs. By taking land cover observations, citizen scientists can help answer these questions when it comes to land cover maps. So, why are these land cover observations so important? Why are they taken in the first place?
We also are looking at how these components are changing over time. So deforestation in the Amazon or across the world, how are cities expanding? A lot of different things to study, and really the view from space is the way that we do it here at NASA. We have big supercomputers that simulate the physics of the atmosphere and the land, the interaction between the Earth systems. It's important to have that, that land cover map. It sets certain parameters. Those models can actually be used to look at current day conditions and weather. So based on these current conditions, what might the Earth look like 50 or 100 years from now? There's an element of understanding, but then also being able to predict into the future, what that might be like, what these changes may mean for us.
Each point shown here represents a real-world measurement of environmental conditions. Scientists use computer models to fill in information where measurements may not exist. By verifying the satellite imagery and using the data for these models, scientists can predict changes in our environment more accurately. One of these scientists using land cover maps to track urbanization as part of her work is Dr. Amita Mehta of NASA's Goddard Space Flight Center.
So urbanization changes terrain as well as characteristics of the surface itself. And so impervious surface is what we look at when we are monitoring flooding. When there are, say, parking lots or cement and concrete surfaces, they increase. So previously, if it was a farmland or something which was not built, and if that is built now, that water previously that could go or percolate in the soil and in the ground now cannot go in, and it stays there. Monitoring helps you to plan for it. So if you see land cover changing, even then you know that how water is going to flow in that region might change. If you have to send rescue out or you have to plan for relief activities, then if you know land cover, then you know where there might be help needed.
By using land cover maps and models that reflect changes over time, scientists can predict where flooding and other events may occur. With a changing climate, these predictions from models and land cover maps can help scientists better understand these changes and help communities prepare for them. But perhaps a more important reason as to why take land cover observations is you get to participate in a community of scientists, citizen scientists, and students.
So it's a very important component that the citizen science and students of the GLOBE program and Globe Observer can contribute to is by really giving us the information on the ground of what they're seeing around them and in front of them. And we hope over time as well how maybe some of these things are changing, because those would be very valuable for science.
I saw the value of having information before a hazard happens, because once that fire went through an area, we can never recreate that data. This is all important for us to share and put together because that's how we understand Earth as a system. All of these things end up affecting where we live, why we live where we do, and why we make some of the choices that we do.
To learn more about Globe Observer, check out the website at observer.globe.gov and download the app to start taking your own observations today.